Hello guys, welcome to this platform. In this lesson, we are going to learn how to add and subtract rational expressions, and we will use least common denominators. So that's what you call LCD, least common denominators. All right, let's go ahead and look at the first example right here. On the first example, I have y divided by 3y minus 2 plus 3 over y minus 5. So for this expression right here, we realize that the denominators are different. They're different. Okay, so we do not have a way to make them overlap. All right. So because of that, we would just multiply them together, and that's what we call the least common denominator. So that's going to be 3y minus 2 times y minus 5. This is just to be compared to, for example, when you're solving fractions. Let's say you have 1 over 2 plus maybe 2 over 3, right? And you can see the denominators are very different. They're not the same. So because they're not the same, yeah, the common denominators will be 2 times 3, which is 6 in this case. So that's what we're doing here. So since the denominators are different, we have like unlike rational expressions. That's what we have. So it's the same way we do. And then we'll now do butterfly, and then now get 3 times 1 is 3. 2 times 2 is 4. And then we'll divide by 2 times 3, which is 6 in this case, and we can combine the numerators to finally end up with 7 over 6, right? And stop right there. Same thing we're going to do here. So now that we combined the denominators here to get this result, so we are now going to do the same process that they call butterfly. So it'll be y times y minus 5, and then you're going to take this result and multiply with that, and it'll be positive 3 in 3y minus 2, and this is what we are getting. So just like we've seen, so here we can simplify further, and just by distributive property we get y squared minus 5y plus 9y. Then we do the final one, which is going to be negative 6, and then you're going to divide all of that by 3y minus 2 going to y minus 5. All right, so we're just going to see how we can simplify these two results here to get y squared plus 4y minus 6 divided by 3y minus 2 and y minus 5. So this is what we get so far, so good. And I'm just looking at if it is possible to simplify the numerator, and I don't think this is possible. So I'm not able to factor the numerator so that I can cross common factors out. So I would just stop right there. Let's do another example. Let's take, for example, we have 4x, maybe 2x. Let's do 2x. Um, let's say we have 2x plus 13 divided by x plus 5. Then we have um, minus 3 over x plus 5. I like this problem. Okay, this problem here is looking like we have the same denominators. So when you have same denominators, it's just like when you're doing 1 over 2 plus 3 over 2. Right, so this is what you call like fractions, and in that case you just keep one of the denominators, you just keep them, they overlap, you just keep that, and you just add the top. So same thing we're going to do here for this rational expressions. So since we have x plus 5 and x plus 5, that means the least common denominator would just be x plus 5, so we're not going to need to multiply. Then for the numerator, so we're looking at we're going to be looking at, say, you have 2x plus 13 minus 3. This is what we're doing here. And we can combine this result here. That simplifies to 2x plus 10, and that's divided by x plus 5. And I'm just going to be careful here. Looking at this result here, I can factor 2 from that to get x plus 5. And I'm going to divide that by x plus 5. And looking at this result here, it looks like I can just cross out this and get my final answer is 2. Okay, so let's try more examples. Let's try more examples. Okay, let's try the next example right here where we are solving number 3. We have 3 over x squared plus 2x minus 1 over x minus 3 over x squared minus 4. Yeah, so for this problem right here, what I'm going to do here is to look at common, denominators, the least common denominators. Okay, so but first to do that, I'm going to factor the denominator here to get x in x plus 2. All right, and then this does not need factoring because it's just single. So here I'm going to factor that to x minus 2 and x plus 2. I hope you recognize this expression here, the famous difference of 2 squares for x squared minus 4. And that's the result right there. So that means my LCD will be x times, okay, I have x plus 2 here repeating here. So I'll just keep that as x plus 2. But then I have, I'm choosing this x, choosing x plus 2 because they repeat. And I'm going to choose x minus 2 next. So this is going to be my least common denominators or lowest common denominator. So this is what I'm needing now. So what I'm going to do here is go back to the fraction and just draw a very long division sign and just plug in my x in x plus 2 and x minus 2 because that's what's going to represent all this 3 now. So, all right, so now what I'm going to do is introduce my first number, which is 3 here, and then I'm going to compare what I have for its denominator to the least common denominator here. So I have x, which checks, and x plus 2 checks. So the only difference is this part here, which is not part of the denominator for the first fraction. So I'm going to now introduce that to the numerator. So this is what we're doing here. So which means we're crossing out everything with the denominator x squared plus 2x, which factors into this. And now whatever is left off of that, we just multiply to the numerator. All right, we move to the next one. Next is -1. And if we look at -1, the only denominator we have for -1 here is just x. But when you look at the common denominator, we have more than that. So what we have introduced will be x plus 2 and x minus 2. That's what we're doing here. So next we get -3. Again, for -3, we have factored that into x minus 2 and x plus 2. And we'll compare these results here for the denominator to the least common denominator. We found the difference is just x, so we just attach the x. So this is what we get. So the only thing we need to do now is to expand and expand. So just do your distributions. So 3 times x will be 3x. 3 times 2 will be -6. And again, we know this is the difference of two squares, which is x plus 2 and x minus 2, which we got in the beginning as x squared minus 4. So which means we're just distributing -1 across to x squared minus 4. So -1 times x squared minus 4. I'm just comparing this result here to that. And that's going to give us a negative of x squared, then positive 4. So I'm just changing the signs because I'm multiplying by -1. All right, so now for the last one, I get -3x. Okay, -3x. And I'm going to divide that by x times x plus 2 and x minus 2. Notice this is x. All right, to simplify further, I will just look at combining like terms and everything. So I have 3x and 3x going away. So and what I have left is just this -6. Okay, -6 and positive 4. We might get -x squared. Yes, plus 4. Yeah, plus 4, that means, oh, that will be -2. Let me just go ahead and do that. I just combine that, get -2. So I'm going to divide that by, what I get here will be x plus 2, x minus 2. All right, so this is what I get. So far, so good. So, and I'll just look around to see if there's anything that I can, get together, anything that I can simplify. So since I don't, so it will just be negative of x squared plus 2, because I can just factor the negative sign and get x, just flip the denominator, right? X minus 2 and what? X plus 2, it does not really matter. Okay, so this is what I get. So which means my whole result will be x squared plus 2 divided by, I know that was x squared minus 4, so I could do x squared minus 4, or just leave it at x minus 2 and x plus 2. And this time, the negative sign that I have here will just go to the middle of the expression. Makes sense? All right, so this is what we get. So the next one here we're going to look at now, it's called compound fractions, and this is how the expressions look like. So let's go ahead and do example 4 here, where we're looking at 3 minus, for example 4, we're looking at 3 minus 9 over y plus 2, all to be divided by 1 minus 5 over y minus 3. This is a compound fraction, okay? All right, so this is what we're going to do here. So now I'm going to work from the denominators first. So let's code that with red color. So let's work with the denominator. I'm in the numerator. So that's going to be 3 minus 9 over y plus 2. All right, but then what I can do is just introduce over 1 for the 3 so that I make them look like they're both fractions. I'm working with the top first. So here, what I can do here, I know that the common denominator for that will be y plus 2, just like we've said. And if it's y plus 2 and we only have nothing, or we have 1 for the denominator, we have 1 for the denominator for 3, that means we just do 3 times y plus 2. And then we go to the next fraction, minus 9, and then y plus 2 and y plus 2 just cancel each other out, and it's just 1, so I'll just leave it like that. So I can simplify further. That means I'm going to get 3y plus 6, I'm just distributing and distributing, and minus 9 over y plus 2. That means I get 3y minus 3 over y plus 2. So this is what I'm getting for the numerator. So I'm going to go for the denominator now. I'm going to color code that in blue. So for that one, I'm going to get 1 minus 5 over y minus 3. So again, I'm going to do over 1. All right, so again, I'll just do the same way. So the common denominator, or the least common denominator, will be y minus 3. Okay, and then because I have just 1 here, it means the numerator will be 1 multiplied to y minus 3. Again, it's just like when you're doing butterflies. Okay, all right, so then here you get negative 5 times 1, which is just negative 5. Yes, because we don't have we'll have the whole factor for the denominator. All right, so this is what we get. And then if we expand further, it will be y minus 3 and minus 5, which is going to give us y minus 8, y minus 8, all over y minus 3. So this is what we get, this result. So we're now going to rewrite that expression here to mean uh, the numerator, which is the red color, and that's going to give us this, right? So it means 3y minus 3 divided by y plus 2. But then you see the division sign here. This division sign here, this long division sign here. I'm going to change that to division like that. Okay, it helps a lot. So I will do that. Y minus 8 over y minus 3. So I can change, I'm now change this to this division here. This allows me to do my keep change flip. So I'm going to keep 3, or I can factor this top here to give 3 in y minus 1 if I wanted to. Yes. Okay, y minus 1 over y plus 2, and I'm going to do times here. I'm going to get y minus 3 over y minus 8. So, and I would just keep change flip. That's exactly what I did. As I kept change and flipped, I'm flipping and I'm flipping. So from here, I see the results that I have, and I'm not able to cross anything out. If there's anything I can cross out, fine. If there's nothing, I would just wrap up everything like that, and that will be my final result. All right, so this is what I get. This is final result. So maybe we can just squeeze in one more example where we're looking at maybe 1 over x to the squared minus 1 over y to the squared divided by uh, y over x squared minus x over y squared. This problem is going to be very interesting. So maybe what I'm going to need to do now is to make more rooms. Okay, so let's go with this. I'm going to work with the numerator first in red. So again, the common denominators will be x squared and y squared because they're different with variables. So common denominator will be x squared and y squared. So I'm working with the numerator first. For the numerator, so it'll be x squared y squared. All right, so and then I will just do butterfly. It'll be y squared minus x squared. So for the denominator, I'm going to color that in blue so that I see what I'm working with. So in that case, that is going to be uh, x squared y squared as well for the common denominator or least common denominator. Again, I will just multiply and multiply, so that's going to be y times y times y squared, which is going to be y to the third, minus x times x squared, which is going to be x to the third. Okay, all right, so this result here will simplify to something nice when I go and combine them. So combining them now for the top number, I got uh, I got a difference of two squares, or maybe just write y squared minus x squared divided by x squared y squared. Then then I'm changing this division sign to division like that so that I can have what y to the third minus x to the third divided by x squared and y squared. So this result here simplifies into y squared minus x squared and over x squared y squared times. So I'm going to do keep change flip. So it'll be x squared y squared over y to the third minus x to the third. So I am now going to cross and cross. So when I cross that result, and I'm going to get something nicer. So let me go ahead and make more room on the left so that I can complete and work with you on this example. Okay, I don't want to move to the next slide and I don't want to lose my videos, but sometimes when I make that move, it doesn't help me keep my slides. So I will just remove this results and we will all be ready to finish off the problem. I think you can actually pause if you think you want to challenge yourself. Just pause the video and then try it out yourself. See what we're getting at this point. Okay, so from here, I'm going to move whatever I have to the other side so that we can all do it together. So we have y to the squared minus x squared, all right, and divided by y to the third minus x to the third. So this is what I am getting, right? Okay, so if you want this, there are ways you can reverse this thing here. It'll be negative of x squared minus y squared because I just wanted my variables to be x and y, not y and x. So again, I can also do that here and that. So when I do this, the negative signs just zero, they just cancel out, and I still get the same expression. So this expression here is equivalent to that expression. All right, so and then I can look at the difference of two squares. So this numerator here will be x minus y and x plus y. I'm going to divide that by the denominator here, which is the difference of cubes. I'm going to do that as x minus y and x squared plus xy plus y squared. I hope this can factor into that. Again, I can check it to see if this is correct. Otherwise, I will have to make changes. Okay, so I know that x times x is x to the 3. X times xy with positive x squared and y. Positive x squared and y. Then plus x times that will be x y to the second power. So next, I'll move with that. It will be negative x squared y. Okay, and then I move with this to that. It will be negative x y squared, and I multiply with that. It will be negative y to the 3. If we had the right factors or expression, we should be looking at opposites crossing themselves out. So this goes with that, and this goes with this. So again, you see what is left. So which means we are good. So now from that expression here, it means that we can actually cross out something. So we could cross out this expression and that factor. So we get x plus y over x squared plus xy plus y squared. So this will now bring us to uh, the final. But then if we look at this result here, just looking at something, I don't know if it's something that you can factor. If it's possible to factor that, why not? But if it's not possible, then that means it will be prime. So that means your final result will just be x plus y divided by x squared plus xy plus y squared. So this is the end of this lesson, and I hope that you come back here from time to time to gain knowledge. Thank you very much, and see you on my next video.